To estimate the usable time of a battery, you need to know its capacity in watt-hours and the power consumption of the device it powers. Let's say the battery has 12.6 watt-hours. To estimate the power consumption, you can use the formula power consumption equals battery voltage times battery current. The battery voltage is usually listed on the battery itself. If not, you can measure it with a voltmeter. The battery current can be measured using a multimeter. Once you know the power consumption, you can calculate the anticipated usable time using the formula usable time equals capacity divided by power consumption. Let's assume a device has a battery voltage of 3.7 volts and a battery current of 200 milliamps, which is 0.2 amps. The power consumption is 3.7 volts times 0.2 amps equals 0.74 watts. Therefore, the usable time is 12.6 watt-hours divided by 0.74 watts equals approximately 17 hours. If the actual usage time is significantly less than the anticipated time calculated, it could indicate a faulty battery. One simple way to check for a faulty battery is to use a battery tester, which can measure the battery's voltage and capacity. If the battery fails to meet the specified voltage or capacity, it may be faulty. To elaborate further, understanding battery capacity and power consumption is crucial for estimating the usable time of any battery-powered device. Let's delve deeper into the formulas and methods involved. Firstly, the capacity of a battery, measured in watt-hours, represents the total amount of energy the battery can store. This value is often prominently displayed on the battery itself. Secondly, power consumption refers to the rate at which the device uses energy, typically measured in watts. Determining the power consumption is essential for calculating how long the battery will last. The formula power consumption equals battery voltage times battery current is fundamental. Battery voltage, measured in volts, is the electrical potential difference across the battery terminals. Battery current, measured in amps, is the rate of flow of electrical charge. If the battery voltage is not readily available, a voltmeter can be used to measure it directly. Similarly, a multimeter can measure the battery current while the device is operating. Once you have both the battery voltage and current, multiply them to obtain the power consumption in watts. The formula usable time equals capacity divided by power consumption allows you to estimate the duration for which the battery can power the device. Ensure that the units are consistent. The capacity should be in watt-hours and the power consumption in watts, resulting in usable time in hours. This calculation provides an estimated usable time, but the actual usage may vary due to factors such as device usage patterns, environmental conditions, and battery age. Consider an example where a device has a battery with a capacity of 12.6 watt-hours. Suppose the device operates at a voltage of 3.7 volts and draws a current of 0.2 amps. The power consumption would be 3.7 volts times 0.2 amps, which equals 0.74 watts. Using the formula for usable time, 12.6 watt-hours divided by 0.74 watts gives approximately 17 hours of estimated usage. If the device consistently falls short of this estimated usage time, it could indicate a potential issue with the battery. A significant discrepancy between the calculated usable time and the actual usage time suggests that the battery may not be performing as expected. This could be due to a variety of factors, including degradation of the battery's internal components, increased internal resistance, or damage to the battery cells. To verify the condition of the battery, a battery tester can be employed. Battery testers are designed to measure various parameters of the battery such as voltage, internal resistance, and capacity. By comparing these measurements to the battery's specifications, you can determine whether the battery is functioning within its normal operating range. If the battery tester indicates that the battery's voltage or capacity is significantly lower than the specified values, it is likely that the battery is faulty and needs to be replaced. In addition to using a battery tester, there are other indicators that can suggest a faulty battery. These include excessive heat generation during charging or discharging, swelling or deformation of the battery casing, and rapid discharge even when the device is not in use. It is important to note that batteries have a limited lifespan and will eventually degrade over time. The lifespan of a battery is affected by factors such as the number of charge and discharge cycles, operating temperature, and storage conditions. As a battery ages, its capacity will gradually decrease, resulting in reduced usable time. Regular maintenance and proper storage can help extend the lifespan of a battery. Avoid exposing batteries to extreme temperatures and store them in a cool, dry place when not in use. Furthermore, consider the impact of different usage patterns on battery life. High-intensity tasks such as gaming or video streaming consume more power than basic tasks such as browsing the internet or reading emails. Adjusting device settings, such as screen brightness and background app refresh, can also help conserve battery power. Understanding these principles will empower you to make informed decisions about battery usage and maintenance. Remember to always follow the manufacturer's instructions when handling and charging batteries to ensure safety and prevent damage. Additionally, consider the environmental impact of batteries and dispose of them properly through designated recycling programs. Batteries contain hazardous materials that can pollute the environment if not disposed of correctly. By following these guidelines, you can maximize the lifespan of your batteries, optimize device performance, and contribute to a more sustainable environment. Let's further explore the nuances of battery testing and what the results might indicate. A battery tester typically assesses several key parameters. Firstly, voltage is measured under load to determine if the battery can maintain a stable voltage level while supplying current. A significant voltage drop under load suggests a high internal resistance, which limits the battery's ability to deliver power. Secondly, internal resistance is measured to assess the battery's ability to conduct current. A high internal resistance indicates that the battery is struggling to supply power efficiently. Thirdly, capacity is estimated by measuring the battery's ability to hold a charge over time. A significant reduction in capacity indicates that the battery is no longer able to store as much energy as it once did. The results from a battery tester should be compared to the battery's specifications to determine if it is functioning within its normal operating range. If any of the parameters fall outside of the specified values, it is likely that the battery is faulty and needs to be replaced. Additionally, consider the type of battery being tested. Different battery chemistries have different characteristics and performance profiles. For example, lithium-ion batteries are commonly used in portable electronic devices due to their high energy density and long lifespan. Lead-acid batteries are often used in automotive applications due to their high current output and relatively low cost. Nickel metal hydride batteries are used in some hybrid vehicles and portable power tools. Understanding the specific characteristics of each battery chemistry is essential for interpreting the results from a battery tester. Furthermore, consider the operating temperature of the battery. Temperature can significantly affect battery performance. Extreme temperatures can reduce battery capacity and lifespan. High temperatures can accelerate the degradation of battery components, while low temperatures can increase internal resistance. It is important to operate batteries within their specified temperature range to ensure optimal performance and longevity. Regular monitoring of battery performance can help identify potential issues before they lead to complete failure. By tracking parameters such as voltage, current, temperature, and capacity over time, you can detect any deviations from the normal operating range and take corrective action. In addition to using a battery tester, there are other diagnostic tools and techniques that can be used to assess battery health. These include electrochemical impedance spectroscopy, which measures the battery's response to alternating current signals, and differential voltage analysis, which identifies changes in a battery's voltage during charging and discharging. These advanced diagnostic techniques can provide valuable insights into the internal workings of the battery and help identify potential failure mechanisms. In conclusion, understanding battery capacity, power consumption, and testing methods is crucial for estimating usable time and identifying faulty batteries. By following the guidelines and using the tools and techniques described, you can maximize battery lifespan, optimize device performance, and ensure safe and reliable operation. Let's elaborate further on the practical steps involved in measuring battery voltage and current using a multimeter. Firstly, ensure that the multimeter is set to the correct mode. For measuring voltage, select the DC voltage setting, typically indicated by a V with a straight line above it. For measuring current, select the DC current setting, typically indicated by an O with a straight line above it. Secondly, connect the multimeter probes to the appropriate terminals. The red probe is connected to the positive terminal and the black probe is connected to the negative terminal. For voltage measurements, connect the probes in parallel with the battery. This means placing the probes across the battery terminals without interrupting the circuit. For current measurements, connect the probes in series with the circuit. This means breaking the circuit and inserting the multimeter probes in between the components. Thirdly, apply power to the circuit and observe the multimeter reading. The voltage reading will indicate the electrical potential difference across the battery terminals. The current reading will indicate the rate of flow of electrical charge through the circuit. It is important to note that current measurements can be more complex than voltage measurements. Measuring current requires breaking the circuit and inserting the multimeter probes in series, which can potentially disrupt the circuit's operation. Additionally, exceeding the multimeter's current rating can damage the instrument. Therefore, it is essential to exercise caution and follow the manufacturer's instructions when measuring current. In some cases, it may be necessary to use a clamp meter to measure current without breaking the circuit. Clamp meters use electromagnetic induction to measure the current flowing through a wire. They are particularly useful for measuring high currents in circuits where it is not practical to break the circuit. Once you have measured the battery voltage and current, you can use these values to calculate the power consumption of the device. Remember that power consumption equals battery voltage times battery current. The result will be the power consumption in watts. Using this value, you can estimate the usable time of the battery. Keep in mind that the estimated usable time is just an approximation. The actual usage time may vary depending on various factors, such as device usage patterns, environmental conditions, and battery age. Regular monitoring of battery performance can help you fine-tune your estimates and identify any potential issues. It is also important to consider the impact of different operating modes on battery life. Many devices have different power-saving modes that can extend battery life by reducing power consumption. For example, reducing screen brightness, turning off Wi-Fi and Bluetooth, and closing unused apps can all help conserve battery power. Experiment with different settings to find the optimal balance between performance and battery life. In addition to these practical tips, it is helpful to understand the underlying principles of battery operation. Batteries are electrochemical devices that convert chemical energy into electrical energy. They consist of one or more electrochemical cells, each of which contains a positive electrode, a negative electrode, and an electrolyte. During discharge, chemical reactions occur at the electrodes, producing a flow of electrons through an external circuit. The electrolyte facilitates the movement of ions between the electrodes, completing the circuit. The type of chemical reactions that occur depends on the battery chemistry. Different battery chemistries have different characteristics in terms of energy density, power output, lifespan, and cost. By understanding these principles, you can better appreciate the complexities of battery technology and make informed decisions about battery selection and usage. Remember to always follow the manufacturer's instructions when handling and charging batteries to ensure safety and prevent damage. Improper handling or charging can lead to battery overheating, leakage, or even explosion. Always use the correct charger for the battery type and never leave batteries unattended while charging. Furthermore, be aware of the environmental impact of batteries. Batteries contain hazardous materials that can pollute the environment if not disposed of properly. Recycle batteries through designated recycling programs whenever possible. By following these guidelines, you can help protect the environment and ensure the responsible use of battery technology. By carefully measuring battery voltage and current, calculating power consumption, and understanding the underlying principles of battery operation, you can effectively estimate usable time and troubleshoot battery-related issues. This knowledge will empower you to make informed decisions about battery usage, maintenance, and replacement. Understanding how batteries work is a fundamental aspect of modern technology, as these devices are critical in powering a vast array of applications from portable electronics to electric vehicles. Knowing how to estimate battery life and identify potential issues is thus a very valuable skill.